Good morning. Welcome back. So last class we did a program on queue operations wherein we inserted an element, deleted, as well as we printed the elements of the queue or the items in the queue at that point. Today we'll be doing the algorithm for deleting an element from a queue, which happens to be very important. Fine. Since we have done a program regarding the same, so it would be easy for you to understand. By this time, you should be familiar with it. It was also a homework question. So I would want you people to keep your notebook and compare it with this. Exactly, it need not be the same, but the logic should always be correct. So in program also, you need not write a program the same way as I write, but then it needs to follow the object oriented programming concepts, as well as basically it should be object oriented program, and then the logic of the program, that is the end result, should be same. So it is not like you need to write the same input output statements, the same variable names and all that. You can give whatever you want, but then provided the logic of the program is same, and you, as long as you follow the syntax, the logic you're aware about, and then getting the desired output what is asked for, then it is fine. Like you can write your program the way you want. So now we will start with the queue delete or DQ. DQ is nothing but an operation on a queue data structure where an element is deleted from the front of the queue. Queue is a linear data structure wherein the element is inserted. That is, the insertion happens from the rear and the deletion happens from the front. So to queue delete or DQ is an operation on the queue wherein the element is deleted from the front of the queue. So here let Q, that is the capital Q, be a queue consisting of n elements. So the size of the queue is n. So the elements would be put in the location 0 to n minus 1. When you insert, the element always gets inserted to the location 0, then 1, 2, 3, 4, like that. It continues up to n minus 1. Once it reaches the n minus 1, queue full, you cannot insert new element. The same way in queue deletion also, the deletion happens from the front. That is, the first element which was inserted into the queue in the 0th location would be the first to be deleted, then the element at location 1, 2, 3, like that up to n minus 1. Front and rear are the pointers which keeps track of the insertion and the deletion. That is, let Q be a queue consisting of n elements. Front and rear are the positions of the front and rear elements of a queue. This algorithm deletes an item at the front end of the queue. Yes, deletion happens from the front, so it deletes the element from the front end of the queue. So shall we start? Please make a note. Step 1. So what should you be doing in step 1? Whenever you're trying to delete, you need to check whether there is any element in the queue or not. So at least for deletion, the queue should have one element. If there are 0 elements in the queue, that is, it's something which is empty and you're trying to delete from an empty queue, it gives rise to an underflow or a queue empty situation. Fine. Check for underflow. So how do I check for that? Check if what? If if front is equal to -1. Front will be -1 only if the queue is empty. Otherwise, it does not -1. Then print empty underflow. Then return back. So this is what you're going to do. Like step 1, if front is equal to -1, that is, you have to check for an underflow condition, check whether there are any elements in the queue or not. If there are no elements in the queue, then front would be -1. So if front is -1, then print queue empty underflow and you return or exit. Fine. And then end if this is it. So step 1 you would have understood because we have done it many times repeatedly. By this time you should, if you have attended the classes properly and listen to the classes, then you shouldn't be making any difference in this, because even if you don't study also, I have repeated it so many times that if you have attended you will be able to write it properly. Next, the step 2, what I should do. If the element is there, at least 1 or n minus, say you can have 1 to n elements in a queue placed between 0 to n minus 1 locations. So, if there is an element in the queue, what I should do? First, I need to delete it. Okay. Delete the front element. Okay. First, you need to delete it. How do I do that? Item is equal to queue of front. Queue of front. So what do I say? Item is equal to queue of front. Whatever is there in the location the front is pointing to, that element gets substituted in the variable item. That is, the RHS gets substituted into LHS. I have done this. After that, step 3. What am I going to do? I need to check whether the element which I deleted was the only element in the queue. If it was the only element, then I need to reposition the front and the rear pointers, because next time when I try to delete an element, then it should give me queue empty, because I deleted in this step, I deleted them in this iteration, I can say, not step, in this iteration I deleted the last element or the only element in the queue. Next time when I try to delete, then it should give me queue empty, because I have deleting the only element, right? So what will queue empty mean? Queue empty means the front should be equal to -1 and rear also should go to -1, because there are no elements. So when you insert again, then you will reposition it to 0, otherwise both will become -1. Getting it? So what should I do? I should check whether the element deleted was the deleted element was the only element in the queue. So how do I do that? I told you how will I do that. You need to first check. See, check whether the element is the only element in the queue. If rear is equal to front, or if front is equal to rear, it means that it is the only element in the queue. When there are only one element in the queue, no other elements, the rear and front would point to the same element. So how will I check? I'll say if rare is equal to, if this is true, right? If rare is equal to front, then, okay, since this is being an algorithm, let me not write the brackets. If front is equal to rare or rare is equal to front, then what I will say, Q has only one element. I will reposition the, if this is true, reposition only one. Q has only one element, so reposition the front and rear, reposition the front and rear pointers. Okay, so I will say if rear is equal to front or front is equal to rear, it means that the Q has only one element. Reposition the front and rear pointers. So front is equal to -1, is equal to -1. Getting it? If they are only element, then I should show that Q is empty, and I will reposition the front and the rear pointers to -1. This is the thing. Else, if this is not true, so what will I do? That is, it is not the only element in the Q. What will I do? Increment the front pointer. Why do I need to increment the front pointer here? Because the elements do not reshuffle or reposition. Suppose if I delete an element at the 0th location, then the element in location 1 will not get shifted to 0, because after 0 the element in 1 should go out, right? Because in a queue, that is that order you have to maintain. I cannot skip the second and third and go back to the fourth in a linear queue. So what I can do is, I, instead of, see, the thing is, the elements do not reallocate or reshuffle. They will not go back to the previous, or they don't change their locations. You just have to change the location of the front pointer. So it has to be incremented by 1. Suppose it is pointing to the 0th location in the 0 element in the 0th location. Once I delete that, it should point to the element at the location 1. So it has to be incremented by 1. Front is equal to front plus 1. Fine. This is what I'm going to do. After that, end if. Yeah. Then step 4. What will I do in step 4? Return element. Or I can say return item. So what are the things I'm going to do? Check for the underflow. If underflow is not true, that is there are elements in my queue, then what will I be doing? I will be checking whether it is the only element after deleting it. Yes, if it is the only element, how will I know? Both front and rear would be pointing to the same element. And then I will reposition the front and rear pointers because I would have deleted the last element or the only element in the queue, and queue would have become empty. If it is not true, that is, it is not the only element, there are still elements in the queue, just increment the front pointer by 1 so that it will be pointing to the element next in the queue to go out and return item. Fine. Hopefully you have understood this. It is very easy, but then it is very difficult. We will see the execution of the program now, which happens to be your lab program also. So now we will see the execution of the program. Before that, we'll just go through the program once. So I have hash include statements here, and then hash define size 5. So my queue can have maximum of 5 elements, and I cannot change the size during the execution of the program. Getting it, I'm going to have array based implementation of the queue, wherein the size or the memory would be allocated during compile time, that is before the execution of the program. So I'm going to have maximum of 5 elements in my queue. You can have more or less. Normally that will have more elements. This is for your like I need to show it to you, so I don't want to have a bigger size queue wherein I need to enter a lot of elements to show you the queue overflow condition, and then I need to show you that the elements will not get reshuffled. So if there is only one element also, how it will show me overflow, that is, it will not allow me to enter the values into or the data into my linear queue. So class is a keyword, queue is the name of the class, which is again an identifier name. After that, private is an access specifier, which states that like anything written in private cannot be accessed outside the class. They are accessible only to the member functions of the class. So what are these? These are the data members of the class queue. Int queue of size. So queue would be of 5 because I have declared size as 5 and it is a constant. I cannot change the value of it. It will not allow me to change the value of size. Only variables can change their values, whereas size is a constant. Then rear, front, I and item. These are of type integer. So these are called the data members of the class returned in the private section of the class. After that, in the public section, I have a constructor queue, and a constructor is a special function declared in the public section of the class which has the same name as the class name and which do not have a return type, not even void. And then you can have constructor parameterized constructors also, but then constructors without any parameters is called a default constructor. In this, I am going to give initial values to rear and front, because if I don't give initial values and I increment or decrement it, it will give me junk values. So whenever you are incrementing or decrementing, make sure that it should have an initial value, otherwise you won't get a proper result. After that, these are the data members of the class. I have void enqueue int. These are called function declarations, which states that what is the return type of the function, what is the name of the function, and how many arguments it is going to take, and what are the types of arguments, what is the data type of the argument. You need not write the formal parameter name. When I define my function, then I can write it, or if you write it here also, it won't give you any error, but data type and number definitely matters. When I say void, the function does not return any value. When I say does not return, like where does it return? Yeah, whenever we return a value, it is returned to the calling function, that is the function in which the function in which this function is called. So when I say I write a function call in main, at the place of the function call, it will return a value if it is a return type is anything apart from void. Getting it? So I say void means the enqueue function does not return any value, but then I'm going to pass an integer argument to it. How many I'm going to pass? I'm going to pass 1. That is why there is only one int over there. Suppose if you are going to pass two integers also, you need to explicitly specify int x comma int y. You cannot say int x comma y. That is not allowed. Each variable should have, or each argument should have, its own data type before that. Then void dequeue, that is, it is not going to pass any arguments. I'm not going to pass any arguments to it, and it is not going to take in any parameters, as well as it is not going to return any value. The same applies to print also, that is, it is not going to take in any arguments or parameters, and it is not going to return any value to the calling function. So these are the member functions, and the top one is the data member. Member functions are declared in the public section of the class, which means that it is accessible outside the class. Then the data members are written in the private section of the class. So only the data members, which is of the class, member functions of the class can access the data members. Otherwise it is non-inheritable as well as accessible. That is, it does not, private data does not get inherited also, as well as it is not accessible outside. And the class has to be terminated with a semicolon. Please pay attention to these small details, because when you do the same, I have seen students facing all these difficulties. Like, you don't have to do a major mistake in your lab, but then in lab exam you will have only 2 hours and you will be tensed. So if you forget this mistake, you will get lot of errors, and literally you will find it very difficult because of one semicolon to debug all those. So make sure the class has to be terminated by a semicolon. The another thing what you need to pay attention when you're writing a program is number of open brackets should be equal of the number of closed brackets in proper places. That is, the body has to be properly enclosed, otherwise again it will not work properly for you. It may give you error, sometimes it may not give you error, but then you will not get the desired output. Here I have Q. Since Q does not return any value, I have written the name of the class to which it belongs to, scope resolution operator. It will tell you what is the scope of that function, to which class does that belong when you declare it inside and define it outside. The function definition will have two parts. One is the function header and the function body. Getting it? Q, scope resolution operator Q. Then rear is equal to -1, front is equal to -1. I am giving initial values to rear and front as -1 because I cannot declare and initialize in a class over here. It will give you error. After that, I am going to write the code. I am writing the code of enqueue. What does enqueue do? It adds and inserts or adds an element into a queue from the rear. So int item is the formal parameter. Then I need to check for what? Check for the overflow condition. Whenever you are inserting an element, then you need to check whether there is any place or not. If there is no place, then you need to give queue full overflow error or a message to the user, and then you need to return. How will you know that? If rear is equal to size -1. Why is size -1 there? Because 0 to size -1 would be size, like 0 to 4 would be 5 elements. Here size is 5, I have already declared, so it will hold 5 elements in the locations from 0 to 4. And I'm using double equal to here because I need to use a relational operator when you're comparing single equal to an assignment operator which assigns the value of RHS to LHS. So don't make mistake in writing single equal to or double equal to, because one equal to symbol like you won't get marks, because if when I correct the paper, if there is a mistake in, or they you don't write the relational operator properly, you won't get any marks, because it completely changes your program will not work. So please pay attention to all these small details. So if suppose there is no, that is overflow condition is not true, it means that I do have space in my queue wherein rare is not pointing to size -1. What you have to do first, you have to go and check whether this is the first element you are entering into the queue. That is the queue empty before that, and whatever you are entering, is this the first element inserted into the queue? When you insert the first element, it should be placed in the location 0, because 0 to n minus 1. So it will start from 0 and then 1, 2, 3, like that it goes till n minus 1. So if it is true, if front is equal to -1, it means that the queue is empty. I need to reposition the front and the rear pointers to 0, because the location of the element which gets inserted first would also be 0. The location of the element which gets deleted first will also be 0. So front is equal to 0 and rear is equal to 0. Else, like it is not the first element, the queue is not full, then increment rare, make it point to a blank location, and in that location queue of rare, whatever is the rare value that would be taken as the index value is equal to the item. Where is item? I am taking it in the calling function. Here the calling function is main. I would be taking it from the user in main and passing it as an argument to the function during the function call. When I call this function, during that time I would be passing item, that is the element which needs to be inserted into the queue, which I would have taken from the user in main to the function as a parameter. The parameter in the function header is called formal parameter, and the parameter in the function call, that is in the calling function during the function call, the parameter I pass is called the actual parameter. So hopefully you have understood this. Next is DQ. DQ is nothing but deleting an element from the queue. So first I need to check whether there are any elements in my queue or not, because if there are no elements I cannot delete. How will I know it's an empty queue? If front is equal to -1, it means that it is an empty queue. So if I say if front is equal to -1, see out queue empty, underflow and return, like that's it. And else, if this is not true, then what will I do? Item is equal to queue of front. First delete the element present at front. So the whatever is the value queue of front, whatever is the value of that, whatever is the value stored or whatever is data stored in that location would get substituted to item. Then you check whether you deleted the element, that is whatever element you deleted was the only element in the queue. If yes, then the queue becomes empty. After deleting it, you need to reposition the front and the rear pointers to -1. Otherwise, you need to just increment front. That is how it works, right? Suppose I delete an element in the 0th location, then it has to move to the next location, that is 1, 2, 3. Like this it goes on deleting whenever the delete function is called. Getting it? Then I'm just printing the deleted element from the queue, and then for your understanding I'm printing the values of the front and the rear pointers. Otherwise in the final exam that is not required. Then print. So print is nothing but it prints the element of the queue, and the elements of the queue would reside between the front and the rear pointers. So that is what I'm going to do over here. After that, anyway, I'm going to display this menu to the user, ask his choice. In switch case, again switch case is a multiple decision making statement where in case 1, 2, 3 and 4 are 4 different valid operations. Either I can insert, I can delete, I can print or I can exit. So none of this, like you enter 5, 6, 7, any other number apart from 1, 2, 3, 4, then it should give me a message that it's an invalid choice. Then it will ask me, do you want to continue? Because I may want to do some more insertions, deletions, or printing of elements in the queue. That is why I have put it in a loop. Until and unless the user says no, this loop would be executed n number of times. I can perform the queue operations. And then once I say no, then it will just print me end of queue operations and get CH. Okay. Hopefully you've understood this. Please have a look. Now we will execute it. Run. See, once I run it, it is showing me NQ, DQ, display and exit. Now I haven't inserted any element inside my queue. My queue is empty. You know that. So let me say too, I want to delete an element from the queue. See, it is showing me queue empty, underflow, right? So here what was I trying to do? I was trying to delete from an empty queue. That is why when I chose that, it showed me there are no elements in the queue, so I cannot delete it. But then I would want to continue with some of the operations, not only like once I exit, I don't want to re-execute this program to delete some, do some other operations. That is why I had put it in a loop. Do you want to continue? I would say yes, I want to continue. I will say I want to do 1. Enter the element in queue is nothing but inserting an element into the queue. I will say 9 is the element. It is printing me the front and the rear pointers. I told you that if it is the first element in the queue, what you're inserting, you need to reposition the front and rear pointers to the 0th location. So 9 is inserted in the 0th location. So when I delete, 9 should be the first element to go out also. And when there is only one element in the queue, both the front and the rear would point to that location. So you can see here the element in the queue is only one, that is 9, and then the front and rear has the same value 0. So whenever there is only one element in the queue, both front and rear would be pointing to that. I'll say yes. Let me let me insert one more element. I'll say 8. So see, rear remains at 0 because I haven't deleted the element, and the element which entered the queue first should be the element which should go out of the queue first, right? That is what first in first out it follows. So front all will not change because I haven't deleted, but then I inserted one more element, so rear should increment. Let me say 3. No, do you want to continue? Yes. Enter your choice. I'll say 3. So it is showing me the queue contents. There are 2 elements in my queue where front is pointing to the 0th element, that is 9, and then rear is pointing to the first element, that is 8, because that was the latest one inserted. Do you want to continue? Yes. I will say I will again enter. Let me say 7. Do you want to continue? Yes. Let me say 1. Enter an element. 6. Do you want to continue? Yes. So I will say 1. Let me say 5. So rear is 4, front is 0. Every iteration of the loop, whenever I choose NQ, that is insertion, rear is getting incremented by 1 because every time you add an element, it goes on increment. Do you want to continue? I'll say yes. 0 to 4 would be 5 elements. My queue is full. So if I try to insert one more element, it should give me error. Let me show you the elements in my queue. So the elements in my queue are 9, 8, 7, 6, 5. So I have inserted that whenever I delete, it should be like 9 should go first, 8 should go second, 7 should go third, 6 should go fourth, and 5 should go in the end. This should be the order of deletion, right? Front first in, first out. So first inserted element was 9, so it should go out. Then the next inserted element was 8, like that. Whichever was inserted prior to the next, that element needs to go out. So my queue has already 5 elements. I have declared size as 5, and then rare has reached its maximum. Now if I try to again insert an element, like I'll say 1, it should give me, see, it is giving me queue full overflow. I cannot insert because my queue is full. So let me say yes. So I'll say not 1, I'll say 2. I'll delete an element. So when I delete, 9 gets deleted. I told you the order should also be that way because 9 was the element at the location 0. That was the first element I inserted into my queue. So that is the first element. When I do the deletion operation, that is the first element which has gone out of the queue. So the element deleted from the queue is 9, front is 1, rear is 4. Let me say yes. Let me delete one more element. So front again is, see, moving to the next element. The deleted element is 8 because after 9 I had pushed in 8. Do you want to continue? I will say yes. 3. So, how many elements are there in my queue now? 7, 6, 5. There are 3 elements. The size of my queue is 5. So, definitely it should allow me to enter because I know that size of my queue is 5. I have deleted 2. So, it should allow me to insert an element. Let us see what it will do. So, 1 is for insertion. Enter element, let me say, but still it is showing me queue full overflow because the elements do not get shuffled or it will not move its location. So the deleted places cannot be reused until and unless you delete all the elements in my queue. So let me say yes. I will say 2. So 3 and 4, yes. I will say again 2. So can I say yes? Now 3. Let me show you the contents of the queue. There is only one element in my queue. Let me see now. Will it allow me to insert? I'll say 1, inserting 9. No, it does not allow me because until and unless the rare value again is reset to -1, you can go back to 0, 1, 2, 3. That is the drawback of linear queue. One of the limitations of linear queue is you cannot reuse that memory which is vacated by the element so that it can be filled by another element. So that is why the circular queues are used, wherein it can be reused. Getting it? So I'll say enter an element. It's full. I cannot do that. Let me do one more. I will say 2. So my queue became empty because that was the only element I showed you in printing also. That was the only element in my queue. So front and rear becomes -1 because after that, after deleting 5, there are no elements in my queue. It became blank. That is why it shows 1, -1 and -1. Let me see whether now it will be allowing me to enter the element. See, now it allows me to enter an element because again it started. Until and unless I delete all the elements, I cannot insert an element into the queue when the rare has reached its maximum. Getting it? Hopefully you have understood. I say no. So end of queue operations. So hopefully you have understood this, and it would have, the execution would have helped you. Now we will again see the different variations of a queue because it is a commonly asked question. So we'll start with a circular queue. So a circular queue, as you can see, is like this. Okay. A circular queue is a linear data structure. It follows the principle of first in, first out. In a circular queue, the last node or the location is connected back to the first node or location to make it as a circle. Yes, the seventh is the last node. Total number of elements are 8 here, that is 0 to 7. So the last node is connected to the first node. The elements are added at the rear and the elements are deleted at front end of the queue. Both front and rear index points to the beginning of the array at the start. Yes, that we have established. That is, when you beginning of the array is when you insert the first element, both rear and front point to the 0th location only. And as and when you go on in inserting elements, rear goes on increasing until you delete, front remains the same. That also I showed you while executing the program. Here the only thing is, since both front and rear, so rear comes here, okay, to the 7th position, and then front is, if I delete 2, 3 elements in a normal linear queue, it will not allow me. I showed you that also. Only one element was there also. It was showing me queue full. But here what happens is, once I delete one element, this place becomes vacant. Then rear can start repeating itself. It can move here so that you can add n number of elements as long as you delete elements from here, so that the elements, whatever the elements vacate, that position can be reused. Okay, the queue is full only when rear index is 1 less than the front index, right? So here n minus 1 and 0, here if the it's just one behind the other, it means that the queue is full, there are no places in the queue. Otherwise, as long as you keep on deleting the elements can be inserted wherein where repeats itself. Getting it? This is a circular queue. The next is a priority queue. So, a priority queue. What do you mean by a priority queue? A priority queue is an extension of queue with the following properties. That is, every item has a priority associated with it. An element with high priority is dequeued, or it can go out of the queue before an element with a low priority. That an element can go out of the queue, suppose if it has a higher priority than the element with a lower priority. The same thing like whenever you have VIP pass, the local, the general, so they can move out. That queue moves faster than this. The same way here also, the element with a higher priority is dequeued before an element with a low priority. But then if two elements have the same priority, then they are served according to their order inserted. Like see, 4 and 5 has the same topmost priority, then 4 first will go and then only the 5. Like that is what it means. Like if two or more elements of the same priority, then you need to go according to the order. Otherwise, you have elements of low priority, elements of higher priority. The preference would be given to the elements of higher priority. That is the priority queue. The next is DQ or double-ended queue. So, DQ or a double-ended queue is a linear list in which elements can be added or removed at either end but not in the middle. Like normal queue is what? An insertion happens from the rear and deletion happens from the front in a normal linear queue. Whereas in a double-ended queue or a DQ, element can be inserted and deleted or removed at both the ends but cannot be deleted from the middle. That is, that sequential order you cannot change. So there are two variations of the double-ended queue, namely the input restricted DQ and the output restricted double-ended queue. Getting it? Input restricted and output restricted are the two variations or the two types of double-ended queue. What is an input restricted queue then? An input restricted queue, double-ended queue, is a double-ended queue which allows insertion at one end of the list but allows deletion at both the ends of the list. That is, input restricted means the input will happen from the rear, but then deletions can happen from both rear and front. That is an input restricted double-ended queue, whereas in an output restricted double-ended queue, the deletion can happen at only one end, but the insertion can happen at both the ends. This is input restricted and that is output restricted DQ. Please have a look. The variations of a queue are definitely important. It's a very commonly asked question. Like almost every question paper would have that. It's a 3 marker. The applications or the variations. One of that is a asked question. And just writing like DQ, double-ended queue, the priority queue, or circular queue, linear queue, these are the variations, yes. But then if it's a 3 marker in the final exam, you will lose 1.5 marks to 2 marks. It depends on the examiner. So if you want the full marks, then please write at least one line for each. Then the operations of a queue, we already did this. That is Q, NQD, Q is empty and size. We have already done all of this. We are left with the applications of a queue. The applications of a queue are used in network communication systems. Why is it network communication systems? That is, for example, you have network is where more or one systems and other network devices are connected. The simplest one is your printer, wherein the print job people would, or different systems, many of them would have fired the print, then they would be waiting in a queue or to share the network resources. So queues are used in network communication system. And even the asynchronous transfer, I think we in the beginning of the class we discussed about that. Queues are also used in time sharing system, in which programs from a queue while waiting can be executed. Okay, queue is used in a keyboard buffer. In call center phone systems, we'll use queues to hold people calling them in an order until a service representative is free. Yes, you can get that this thing also, right? Wherein they'll say you're in a queue, please wait. Then various features of operating system, the OS, then types of scheduling algorithms, round robin techniques for your CPU time, then printer server routines, which we discussed, and various application softwares is based on queue data structure. So, by this, we come to the end of queues, and then the next data structure is linked lists. That is also important. Please pay attention to that. Hopefully, you have understood till now. And this also is very important. If you don't have a textbook, please make a note, because in the test it's a commonly asked questions, the variation of a queue as well as applications of a queue. Now please make a note of your homework question. The first one is explain the variations. I can say state and explain. Fine. State and explain the variations of queues. The second question is write list the applications of queues. So these are your 2 homework questions. Please make a note, and these are all exam asked questions also. So hopefully you've understood today's class. Tomorrow we'll be starting with linked lists. Take care, stay safe. See you tomorrow. Bye bye.